57. 86. 97. 56. 89. 57. 84. 79. 63. 89. 977. 577. 639. 859. 587. 3,487. 9,627. 6,589. 8,639. 4,897. 96. 80. 62. 90. 82. 82. 67. 65. 85. 81. 82. 616. 1,158. 1,184. 6,187. 7,990.
125. 100. 125. 100. 150. 175. 275. 225. 150. 275. 175. 300. 400. 550.
94. 74. 53. 92. 92. 61. 92. 65. 71. 74. 92. 53. 62. 82. 93. 84. 60. 35. 5. 29. 26. 64. 65. $25. $57. $24. $43. $17.
Left to right addition is an easy way to add numbers in your head that helps you become quite fast.
We know that you already know how to add, but you probably do it in the opposite direction.
And that's okay. The traditional method works great. The only problem is, when you use it, you need to remember all these little in-between steps.
And you know, all those little in-between steps, they take time.
One reason left to right addition is so much faster is that our eyes are accustomed to reading in a left to right pattern. We read like that every day.
For instance, if I were going to sound out a big word like brontosaurus. Oh, hi! I'd start on the left and work to the right. Brontosaurus.
That's right. That's the way it works with words. Left to right addition makes even more sense when you think about the way numbers work. Because after all, the numbers to the left have the greatest value. So you add those first.
You know, if you were going to give me 2 big bags filled with money...
I don't think I'd do that.
Well, let's just imagine that you did.
Okay.
One bag was filled with coins, the other bag filled with bills. I'd sure count the bills first.
Of course you would, because the bills have the greatest value. That's left to right addition. I like to think of left to right addition as just easy addition facts lined up close together. Here's a problem that shows you what I mean. 4,231 plus 2,638.
Don't be fooled by its size. It's really just 4 plus 2, 2 plus 6, 3 plus 3, and 1 plus 8. Breaking big problems into smaller ones makes them easier to handle.
And the thing that really speeds us along is that we get to start speaking out the answer before we're even finished figuring the problem.
Huh?
Well, you see, if we're adding from left to right, the first digits we add together are the first part of the answer that we say. That'll make sense in a minute. For now, find the place value of the numbers furthest left.
Okay, let's see. Place value. We have ones, tens, hundreds, thousands. The 4 and the 2 are in the thousands place, so we say 6,869.
Great! Let's look at another. 135 plus 243.
Okay, the 1 and the 2 are in the hundreds place, so when we add them, we say 378.
Do you think they're adding them with us?
I don't know.
Add the numbers along with us in your head and say the answers as we do.
Here's a good one. 621 plus 274. Okay, 6 and 2 are in the hundreds place again, so we say 895.
Are you ready for a bigger one?
Sure they are.
We'll try this and we'll help you out. 2,724 plus 5,162. Now let's see, we have hundreds, thousands. Our 2 and our 5 are in the thousands place. So we say 7,886. Not bad.
Yeah.
Let's do one more together. 3,285 plus 1,402. We're in the thousands place again, so we say 4,687.
You know that sometimes two digits add to 10 or more, like 35 plus 18. No problem with the 3 and the 1 in the tens column, that's 40. But 5 and 8 make 13, and that's too much for the ones place.
Well, whenever that happens, I just back up and fix the previous number. The 110 from the 13 combines with the 4 tens we already have to make 50. And then the 3 from the 13 stays in the ones column. Let's do a few together and I think they'll get the idea. 26 plus 17. 2 tens and 1 10 are 30. 6 and 7 are 13.
Whoops! Back up and fix the last number. 43.
Here's another. 28 plus 43. 60.
Oops! 71. I just do the fix-ups by writing right over the top of the last number. But if I'm just saying my answers aloud, I just correct what I said before.
Shall we try a longer problem? 491 plus 237. Now let's see, we're in the hundreds place, so we say 728. How about one more together? 5,246 plus 1,329. This time we start with the thousands place, so we have 6,560.
Oops! 75. If you like going to the arcade and playing the video games, you're probably already pretty good at counting quarters.
Yeah, and knowing how to count quarters can really help you with your math. Here's $3 in quarters. Count them with me. 25, 50, 75, $1. $1.25, $1.50, $1.75, $2. $2.25, $2.50, $2.75, $3.
Be sure to notice that repeating pattern of 25, 50, 75, and 100. You can use that pattern and think about quarters to help you add in your head. Suppose you had 125 plus 50.
Well, I would think of that like $1.25 plus 2 more quarters. Well, we have then $1.50, $1.75. My answer, 175. Let's see how thinking about money can help add 75 plus 75.
Here's a couple of ways I might handle that. First, we could just use that same pattern and count on by quarters. Since we know that 3 quarters is 75, we start with the 75 first and count on 3 more quarters, saying 75, $1, $1.25, $1.50. The answer is 150.
Now the second way of looking at it may seem even more natural to you. You take the quarter from the second 75 cents to make the first group into $1. Then you see that the remaining 2 quarters are 50 cents. So you know you have $1.50.
Let's do a more complicated problem with them, like 325 plus 50 plus 75.
Well, that's not hard when you remember money. Right away, I'd put the 75 cents with the quarter from the $3.25 to make $4. Well, then we have 50 cents to add on, making $4.50, or $450 if it's not money we're dealing with.
Sharing is probably the last thing I want to think about when I've got a candy bar. But sharing can make things a whole lot easier when you're adding numbers.
I think I'd rather share the candy bar.
No way! I'm thinking about the sharing for ease method of adding. I'll demonstrate this with candy bars. Imagine each bar is divided into 10 equal sections.
So a candy bar is a 10, and each of its sections is a 1.
Yeah! Say we had 20 28 plus 46. Remember, it's always easier to add an even 10 to a number. So, I'm going to share some of the ones from one number to make the other number an even 10. 28 is the same as 2 10s and 8 ones. 46 is 4 10s and 6 ones. 28 only needs 2 more ones to be a 10, so I'll share 2 from 46 with a 28. Now, by sharing, I have made the easy problem 30 plus 44. I can add that number in my head. The answer is 74.
Well, I want to try one of those. 24 plus 57. Now, it would only take 3 more ones for the 57 to be an even 60. If the 24 shares 3 of its ones, that leaves us with 21 plus 60. Easy, 81.
Do this problem with me. 47 plus 45. How many should I take from the 47 to share with the 45?
Well, 5 will do it.
That's right. Sharing 5 will leave 42 plus 50, or 92. I think we should try one using only the numbers this time, don't you?
Well, then can I eat the candy bars?
No, not yet. Try this problem. 36 plus 49.
Well, we could have the 36 share 1 with the 49. And that makes the problem very simple. 50 plus 35 is 85.
Stepping up or down is another method we can use to make subtraction problems easier. To help you get a picture of the idea, think about climbing stairs with a friend. Each step is numbered from the bottom up. At first, your friend is 4 steps higher than you. If you both go up 1 step, your friend is still 4 steps higher than you. If you each go up 2 steps, your friend will still be 4 steps higher than you. As long as you both go the same number of steps in the same direction, the distance between you stays the same. Suppose your friend runs faster for a little bit. By the time she is at step 87, you're only at step 49. You can find out how many steps ahead she is by subtracting 49 from 87. That's not an easy subtraction to do in your head.
Well, I remember when we were working with addition, working with even 10s always made things easier. Is there some way that can work with subtraction?
Sure. 49 is really close to the even 50. All you'd have to do is go up 1 step to 50, and you'd have an easy subtraction.
Well, yeah, but wouldn't that mess up the answer?
Not if your friend went up 1 step the same as you did. Remember, then the distance between you would be the same.
Okay. Well, my friend should go up 1 step to 88. Well, now I get it. My subtraction is 88 minus 50. That's easy. She is 38 steps higher than I am.
Here's another problem where stepping up will help us. 43 minus 28. Notice that 28 is just 2 steps away from the easy to subtract 30. Since I'm increasing 28 by 2, I must increase 43 by 2 steps, making it 45. Now that's a simple subtraction. 45 minus 30 is 15.
You're right, that is easy. Now, did you say that stepping down would help too?
Sure. We'll take 95 minus 61, for example. It's easiest if we make the number we're subtracting be even 10. 61 is only 1 step above 60. Since I'm stepping down 1 step to 60, 95 must go down 1 step to 94. That gives us 94 minus 60. The difference is 34.
Here's one more stepping down problem that we can do together. 86 minus 32. Now, we could just step down the 2 steps to an even 30. Then 86 goes down 2 steps. So we subtract 84 minus 30, and we get 54.